module with pen file also we can read a module dimension, module worksheet, module characteristics, module current voltage, like this one. Those things we need to read to design a solar system. Then once we are selecting that number of module in series, then total capacity of, say here, uh, 245 kilowatt module. So DC ratio called another thing, DC capacity divided by AC capacity. That means 245 divided by 160. That is called 1.1. So that is called DC ratio or phenom ratio. So we need to optimize that DC ratio also based on that inverter size or clipping at the inverter. Once it is done, there will be different losses we are defining into this window. That is called ohmic loss, means DC cable loss. Solar power module will be generating DC power which will be connected to the inverter. So this will be the loss due to DC cable. Then we need to define a AC loss also from inverter to LT panel. So generally we need to estimate what is the distance of the AC cable, or we need to estimate what is the percentage loss of AC cable. Accordingly, we need to define a DC cable loss as well as AC cable loss into the system. Then module quality loss, because it is basically, even if we say that 545 working module, it is not exactly 545, it will be maybe more than 545, maybe say 550. So if it is 550, that means extra generation is possible. So instead of loss, it will be actually gain. So generally it will be gain for most of the solar PV module. So that is terminology called positive pinning. Module will be generating more power than whatever they are giving as an nameplate. Then soiling loss, what are the loss due to soiling of the module. Then what are the auxiliary loss of the solar plant. So we used to calculate what will be the auxiliary loss in terms of watt per kilowatt of the plant capacity. So this will be all the calculation will be separate exercise, and based on that inputs we will be giving this one. Then plant will not be available throughout the year for 100%. So we used to give how much percentage will be available for the plant. So that is 1% is unavailable of the plant. So once it is done, and if we want to give a power factor, if any country has requirement of power factor, then we need to give a power factor here. So whether it will be 0.98 or 0.95, that also based on that country grid code, we need to give that power factor requirement in this scenario. Then sometimes few country or even India, there is a restriction of power input into the grid, because grid has some limitations. So they used to say that more than this much power you cannot pump into the grid. So those are the things we need to give. Once it is done, then we used to do simulation into the software. So this will take few minutes time to estimate that energy, how much it is possible. So once we'll be doing that one, then from 245 kilowatt peak DC plant, or I will say that 160 kilowatt AC plant is defined by inverter capacity. It is generating how much energy. So we have seen that load requirement considering 20% of the battery is 333 kilowatt hour. So if we install that 45 kilowatt, then we will be getting 330 kilowatt hour of energy in a year. So this software will be giving one type of a report that is called a PVC report. So this report will be dictating whole system design, how it looks like. So this report will be looks like, I am taking time, maybe I will be having another few minutes, then I am done. So this is the one typical report it will be generating. From that report we will be understanding that one, and even this report also will be giving one typical SLD. So here 18 modules are connected into series to form strings. So there will be 12 string into one inverter, and another case there will be 13 strings into another inverter. Then it will be connected to the LT panel. Then it will be connected further to the load. So this is the way we are designing a solar system into by use of PVC software. So that's all for my side. now I think time also finished, so I am not sure how. So sorry for